Hey, this is Mr. Ward, and welcome to the PreAlgebra Do Now 29.2. I'm going to blow this up just a little bit because it'll be easier to see some of this stuff if I do. So we're going to be considering which graph here shows the sequence of transformations described below and why. Okay, so we have ABC, and ABC is this little faint dashed one. And it's at 2, 1, and 4, 2, and 4, 1. Those are the vertices or corners of that triangle. Now, we're rotating at 90 degrees counterclockwise about the origin and then reflecting it across the x-axis. So let's take a look at the options. So the first one gets reflected across the x-axis and then rotated 90 degrees clockwise. So that's a nope. So no. Okay. And then the B, okay, B gets rotated here. So we're going, so you can tell it's rotated because it goes from 4, 1 to -1, 4. Okay. And so we switch the places of the 4 and the 1 to a 1 and a 4, but X changed signs once it had been swapped. So when that happens, you have either a 90-degree rotation. When X changes signs, you're doing a 90-degree rotation counterclockwise. When Y changes signs, you're doing a 90-degree rotation clockwise. So this is counterclockwise, going this direction, and then it flips over the x-axis. This one does a 90-degree rotation counterclockwise, but then flips over the y-axis. So this one is the winner. So we're going to say B because it shows a 90-degree counterclockwise rotation. X and Y change positions or swap positions. And X, the new X, changes signs. The reflection is across x-axis and the y values change signs. Okay, so those are things that have happened when we did those transformations. Now the next one, we have two transformations being used to map the pentagon JKLMN here, JKLMN, and we're mapping it over here to J double prime, K double prime, L double prime, M double prime, N double prime. So it's the double image of this. So we've done two transformations. Let's consider these. So a translation and then a rotation. So a translation would be a slide up or down, and then a rotation. Well, both of those are rigid transformations, and we have a change of size. So no, neither of those. Reflection and a dilation, that's a possibility because there's a dilation. A rotation and dilation, that's a possibility because there's a dilation, and a dilation and a translation. So all three of those are possibilities because there is a size change. There has to have been a dilation. So there's two types of transformations. So let's consider a reflection. So if this were reflected across maybe this line right here, that axis, L and N would be, well, N would have been here, L would be here, K would be here, and J would be here. Okay, and what am I missing? and M would be here. So we're going like this. Okay, so that would be the reflection. Now then, a dilation. Could we get a dilation that brought us to here? Well, the question would be, is there some point? Can we draw lines from all of these? Let's see, that's L, that actually end up in the same place. Kind of, maybe? I don't think so. Maybe we could have a dilation right here. We'll consider that. That's a possibility. I'm going to erase all that business, though, because it's kind of crazy messy. Okay, so that's a possibility. It's a little hard to tell what the thickness of my line drawer, unfortunately. Now let's consider a rotation and a dilation. Well, a rotation couldn't possibly end up reflecting. There's definitely a reflection involved. So I'm leaning now back towards this one, okay? Because this one doesn't have a reflection. So these two are out. So I'm definitely going to say, actually, I'm going to reconsider my original idea. I'm going to say, yes, it had to be a reflection. So it's the only one that has a reflection. And then the dilation did look like it was plausible. It was just I wasn't confident with my line drawing tool. I think that in class, when I'm doing it, I'll have a better line drawing tool that I can use, and I'll be able to test this out more clearly. But I'm going to go with B on the grounds that it has a reflection and none of the others do. So let's go ahead and say B, because it is only one that has a reflection. Okay, and I'm going to add, we will test out the dilation in class with a better line drawing tool. Okay, but as long as I can draw a line, take this and make a reflection and draw lines that go through, say, L prime and L double prime, and N prime and N double prime and J prime and J double prime, and they'll all end up converging in the same spot, then that's a pretty good sign we have a dilation. Okay, let's continue. I think we are done with this do now, and I will go ahead and stop.